welcome back, ladies and gentlemen, boys and girls, angels and demons and monsters and serpents, to Brothers of the Serpent podcast, coming to you not live from the 10 by 10 by 10 tangent cube of science, nestled amongst the dusty bones of an ancient seabed high atop the Everest Plateau. And we have a great show for you guys tonight. This is one you may want to watch the YouTube video on, but you can listen. But there were slides that really helped get some of the geometry and math across. Because our guest today was Ed Nightingale with his work on the Giza Template. And it is complex but fascinating. So
yeah. Lots of visuals that are very helpful.
Yeah.
So even if you're listening, maybe you jump into the YouTube channel and check out the slides, because the slides weren't moving fast.
Yeah.
So there are, we'll sit on a slide for a while, talk about it, so you can always go check it out. I'm not going to claim that Russ is going to post these slides in the show notes.
I didn't get the slides, so yeah.
We'd have to take screen captures.
Yeah.
But, so that's not going to happen.
Don't claim that.
I won't claim that. But History Shift will do a phenomenal job in a few days.
That's
Maybe.
right. That's right.
Not going to claim when he's going to get that out.
Yeah. No claims being made here, ladies and gentlemen, except for this is a fascinating show. And it's clear also that we are going to have Ed on many times in the future. So we talked to him about that tonight we were trying to give a kind of an overview and sort of get an idea of what his process is and what he's looking at. And I think we did manage to do that. He said that he kind of had a finale that we didn't make it to, but we'll get it on the next show. There's just a whole bunch of mind-blowing stuff in this stuff that he's figured out. And it is detailed with numbers.
And all about pyramids.
It is all about the pyramids and the Sphinx and Giza and stars and stellar configurations and precession and just all the stuff we like on the show. So,
yep.
And I proved that I can't math.
Yep, that's right. Totally failed to math. And I was too dumb to figure out that you were wrong until way later. But anyways, no worries.
Oh, well.
But he has a book out, the Giza Template. Go get it.
That's right.
We're going to go get it. We got to do a deep dive into this stuff, so that'll be coming.
Yeah,
in,
and I've seen
episodes.
I've seen that some of you have already gotten it, so that's good. Saw some pictures posted. And yeah, Kyle and I are going to get it, and we're going to go through it. And we're going to have him back on and really dive into this material because it is really interesting.
Yep. So without further ado, here is our interview with Ed Nightingale.
Welcome back, ladies and gentlemen, to Brothers of the Serpent podcast. We are joined today by Ed Nightingale. This guy has come highly recommended to us by Randall Carlson and by Brad and by Laird Scranton and several other people. So we've got Ed on, and he's got a ton of fantastic material to go through. So we are extremely glad to have you on, Ed. Thanks for coming on the show.
Great. Well, thanks for having me, guys. I've really enjoyed you guys' work with Randall and my good buddy Laird there. I appreciate all those guys giving me a nod there, and got a lot of interesting things to share for sure.
Yeah, and you're going to be sharing with images too. So I recommend to anyone listening that you might want to go check out the YouTube version of this, because Ed's got a lot of diagrams and other images that he's going to be showing us, right, Ed?
Yeah, I got lots of that, and really the work actually, warrants the graphics.
Right.
Understand it much easier.
So let's start out with, what's your background and how did you end up getting into all this interesting stuff, the Giza Template?
Well, my background is, as far as my career, I'm a wood carver, and I've been woodworking since really I had interest as a young man, and pretty much right out of high school, got into the woodworking with some really talented people too, by the way, that I began my work with, and was fortunate to get into some work where I was working on the Trinity Church in New York City with some guys. We were doing some Gothic tracery arch windows for the church, and we got a little tour of the inside of the church by the landlord, and he took us on a tour up to the steeple in the church, and the stonework in that church really just fascinated me, and the whole the stonework and how they were able to do that many years ago really kind of got me hooked on a little bit more of the architecture of the the older architecture and stuff, and that kind of led into more of my interest in Giza, and I've had an interest in that since I was quite young, and I kind of had an idea how the whole thing might be put together from a geometric standpoint, and gave it a try, and discovered really how they put Giza together and why it's there, and the message it contains, the information it contains. It's a repository, and that's where I'm up to currently, but it's been a lot of years of research on this. I started in 1997 when I went with John Anthony West. I was able to be fortunate enough to get involved with him early on and see Egypt from his standpoint, and that's where my search started in 97, trying to understand the architectural layout from an architect's point of view, as that was really my trade was, millwork and measuring and building architectural millwork, furniture, etc. And so here I am today. We're talking with you guys, and got I put my book out in 2014, the Giza Template, Temple Grail Earth Measure, with my good buddy Laird Scranton helped me out with it. I found it very difficult for me to try to write this or explain this information in a book. How was I to present it? It was a very difficult thing to try to do, and I tried to present it from an architect's standpoint to demonstrate how it was put together as a repository of information, and that's what we're looking at. And
so you think it's fully a repository? Do you think it had any like other practical purpose? Like Chris Dunn thinks power plants or anything like that, or is it fully a repository?
Well, I'm glad you asked that too, because this does not take away any possibility that it could be a machine of some kind or some kind of other use. It does not destroy that at all whatsoever.
Okay.
It actually enhances it in a way that what's understood here at Giza, once you understand this template, you understand, I believe, the knowledge of how they did move and cut these stones, and it was essentially using vibration and frequencies. And this whole template is really how this whole understanding of how nature works. Nature uses mathematics, and we can see that in the Fibonacci spiral, and that's really a huge part of all this. And we'll be getting into all that, show you how the Fibonacci's is created and how it fits in with the Giza plan, and how the Fibonacci spiral and Barnard's loop is all part of this trajectory that our sun is on. And that's really, the bottom line, I think, and the information. It not only gives you the technical aspect of how to map this trajectory, it literally maps the trajectory of our sun, and as it goes through, the this journey, this path, it has certain alignments that are relative to other star systems and in relationship to our pole. And these alignments that seem to line up quite, it's startling, really. They align with around the Younger Dryas period, the end of the Ice Age, and pretty much Randall Carlson's work and the Comet Research Group and all these guys. This all ties this all together. Essentially, what we'll be getting to a little later on in this is how the path of the sun, as it crosses these alignments, has potential for these filaments that are connecting, I think, these stars with their place of birth. And these filaments that we can see as we view we're in a spiral galaxy in a spiral arm of Orion, the Orion spiral arm. So what I'm suggesting here that this trajectory and map will show is that, yes, indeed, our sun is on a spiral path moving away from Orion's nebula in a spiral path.
So that sort of gives a whole different interpretation of all of the Orion mythology in terms of Egypt. Like it wasn't, they're using man or the pharaoh or the king or, as that we came from Orion, but you're saying more it's like, well, the whole system came from Orion to the point that we're at now.
Son, I've got some really good slides. I don't know that I have them on. I have them on another hard drive. I should have grabbed them for tonight, but we'll have to get into this at another point in time. But they've got great pictures NASA has from Hubble and I think even some other telescopes showing the star birthing processes in the nebula of Orion. And where these suns are on this filament or a spiral like snake whipping out of the
I've seen those. It's very it's very cool looking. Yeah.
And they're separated by light years, these suns shown in different ages along this spiral path. And I think what you're looking at right there is exactly what our sun happened with our sun, and not only our sun, but Sirius and the Pleiades. Because they're mapping out in this map, it maps out the spiral path for our sun. It maps out the spiral path for the Pleiades, and it maps out the spiral path of Sirius. There's 3 separate spirals that originate in Orion's nebula. And it's so precise how this works out that I'm going to just be inundating you with coincidences of how many layers deep this goes as to being precise, how these spirals all line up. And this trajectory, and again, how certain points in our this great year have alignments. It's just astrology. I mean, there used to be not a difference between astrology and astronomy.
Right.
There used to be more the same type of thing. Now, what astrology is about is alignments, right? Your planets are aligning at certain points. So they're talking about an energy of certain alignments that seem to have an effect.
Yeah.
So this is no different. Now we're not talking about just alignments with the planets. Now we're talking about how our sun and our solar system is aligned with other suns and how they interact with our closest neighbors. And really, Sirius is, a very close neighbor and on part of this relationship that we has with our sun. And it's the how can I say this? Well,
I have a question real quick. is the alignment, are the alignments based on our point of view from Earth, or are you talking about alignments that are actually happening between the sun, say like in the center of the galaxy and these other star systems, or is this from our perspective here?
Well, what it does, it gives us, what we're going to be doing is they give us two things to look at Giza. Giza is made up, and I really should probably start using some slides to go along with this.
Yeah, let's get into the slides, man. Let's move forward.
Yeah, because I'm actually we'll be right up to that point pretty quick here. So, let's just start with my book here, the Giza Template, yep. Temple Grail, Earth Measure. The word again, I mentioned to you earlier about the word template and temple can be interchangeable. Template is a later adaptation from the word temple. Okay. So this template that I'm going to show here is, can be understood as a temple as well as a template. The word graal can mean step or position. I believe it's an old French. Graal means step or position.
It sounds like the Grail.
Yeah.
Like the Holy Grail or something.
That's what I'm trying to say here. I think that I'm going to just come right out and say some things here that might sound like I'm saying quite a bit, but there's evidence to back all this up. But yes, the Grail, I think, is a lot of information. And this information is about the science and the earlier civilization that had that knowledge, and it's been passed down in this template or temple. And
awesome.
It's the basis to which our measurement system, our measuring system, how we would be able to measure Earth and be able to start measuring things. That would be the only way we would know how our trajectory, how we were moving through space as our sun, was moving, in order to map all this. This knowledge is all in this coordinate system. So this stepper position or Grail is in this template.
Oh, okay. I see.
So, okay, yeah, I've been going a long way around to get there, but okay. So this here is a shot of, I believe it's called the fish's mouth in Orion. So it's the center of a star-birthing nebula, called the fish's mouth, and we'll just have to remember this for a little later about the fish and the understanding of where we're going to be going with fish. Another term for a fisherman is what, you guys? Anybody?
Angler?
So a fisherman is an angler. So we're just, when we use the term fish, as we go through this study here, you can equate fish as an angler.
All right.
And just use, you understand what I'm saying? They're using the fish as an angler. Huh. But if you just replace, anytime they're talking about fish, just replace the word angle or angler, and it gives a whole new meaning to a whole lot of mythology.
Okay. You're talking, we're getting into geometry here, like the angler.
The angler, yeah. Okay.
Right, okay. Right. An angler of men.
Yeah.
Yes. Okay.
Okay.
And a ruler.
Yeah. Ruler is.
Or a fisher of men.
Yes.
An angler of men. Very okay. Cool. So just keep that in mind as we go through this. The fish and the symbol of the fish and its origins here in the fish's mouth. Okay. So we'll move forward. So as above, so below. So now we're looking here at the Giza, and this is one of the first questions everybody, I guess, would think of is, why was this place constructed? That such effort went into this that it's mind-boggling today with all our technology and all our equipment and machinery. To go over there and experience Giza is mind-blowing. I mean, you can't even imagine. I don't know how big of a piece of property you guys have there in your farm, but if you can take 13 acres of that and imagine that's the base of a pyramid, that stands, 400 and, feet high here. It's mind blowing anyhow.
Absolutely.
So why was it constructed? Well, I went in there with my hypothesis, and I certainly was not the only one. There was a lot of people who have put this forth, is that Giza is a repository, that within this architecture and this design, there is ancient scientific knowledge of measures of the earth and of the heavens, and they're using geometry and mathematics to put it in this architecture. And within this, it all precisely charts the motions of the 25,000-year precessional cycle, known as we know, as a great year, and then preserving this knowledge for future generations. So this is, I believe, the main point to Giza. Now, again, I don't count out any kind of other mechanical or machine-like powers of the pyramid or anything. That does not negate any of that. It can still happen. But what they did do within these architectural structures was encoded the knowledge of really the bottom line or the end message here is charting these motions of the precessional cycle.
Yeah, we've talked about how in modern times it's, we've asked the question, would we as a society go to all of that effort just to make something for future generations, that had no utility to ourselves at the time? So it does seem like something that it would have both purposes, right? It would be useful to those who lived in the time of its building, but also if you were going to go to this monumental effort, you might as well make it something that's also going to be useful to future generations long after you're gone.
Absolutely. And, you think about this too. One of the main things at Giza, and I know everybody talks about it and wonders about it, but it can be easily answered. And the question is, why are there no hieroglyphics?
Yes.
Yep.
At Giza? And there's a very obvious and simple answer, and that is that the message was not to be in a language of hieroglyphics. It's meant to be in a language of mathematics and geometry. And any hieroglyphics would take away from the fact that they wanted you to know this ain't about hieroglyphs and Khufu's tomb and tombs of the pharaohs and all that. That's not what this is about. This is about geometry and mathematics and proportion.
So there have been some I've heard. I can't give you any sources of where this came from, but people talk about how before the casing stones were removed, it's the possibility that they were all completely covered in hieroglyphics and all that. Do you think there's no?
That might have been added.
Oh yeah,
it's possible, but I think if that was the case, that they certainly weren't counting on those hieroglyphics lasting for tens of thousands of years, whereas geometry would.
Yeah.
Right. Okay.
So
point.
Yes, there could have been hieroglyphs all over it. It really, and that won't change anything that has to do with the geometry and the positions of the architectural structures themselves.
Yeah, this might be jumping the gun a bit, but do you think that your work might date the building of the structures at all, or is that not something you look at?
I think so. I think it does, and it backs up the King's List. That goes back 36,000 years, I'll show you how Regulus and Leo have everything to do with that 36,000 year king list. And I think that because at that time, 36,000 years ago, there was a geometric alignment, which Regulus was heliacal rising with the sun on this date back in 36,000 years present. So Regulus is on the ecliptic, which is the base of the zodiac and the constellations of the zodiac. So from a galactic alignment back to 36,000 years ago when Regulus was aligned, I think at that point in time, you'll see it. I'll show it to you as we get a little further in here.
All right.
About how that alignment occurs and how this calendar lines up, and it lines up the beginnings. Well, actually, what we'll precisely be looking at is 3 different calendars. That would be the beginning of the Hebrew calendar, the beginning of the Mayan calendar at 3114 BC, and the Gregorian calendar from the year 0.
All right.
How all these fit together precisely, and they're each identifying another motion, and the motions of Sirius and the Pleiades, and how they relate to Orion's nebula and of course the sun. So we can think of the sun as being on the spiral path, as well as Sirius and as well as the Pleiades, and that they emanated, all 3 emanated from Orion's nebula. So that you can just picture that. But so anyhow, I guess I get moving on here a little bit. What I wanted to say here is that there's stuff that I probably have already said that people are going to be saying, "Oh man, this is
nope,
sounds out there."
Probably not on our show, but
yeah.
Man,
not our listeners.
But here's what I ask of everybody too: allow me to present the evidence, and I won't even have to support the evidence. I'll just present you the evidence, and you can make up your own mind. But there's a quote here I kind of like. It's about it. It goes like this: it's, "No testimony is sufficient to establish a miracle, unless the testimony be such a kind that its falsehood would be more miraculous than the fact which it endeavors to establish."
Oh yeah.
So I'm gonna, and we can add to that: extraordinary claims require extraordinary evidence. That's where Carl Sagan was really kind of pulling that his quote there from, is this other quote. I forget who it was by, but so I'm going to make some claims here that are going to be extraordinary, but I'm also going to present you with the evidence. But now there's a lot to this, and there's a lot of to prove this in a scientific manner. I need to go through some facts, and there's numbers and geometry, and this is a very difficult thing to present in one show. So we'll, as we talked about earlier, we'll have to go through other things. But
yeah, we'll do multiple episodes, as long as it takes.
We can talk about pyramids for as many shows as you want, man.
That's right.
I don't know what you just opened yourself up to there, buddy. Okay, so let's move on with some of this evidence. So as I explained to you there, I'd gone over with John Anthony West in 1997 to Giza, and before I went over what I was really looking for is all right, this is a satellite image right here of Giza and the 3 pyramids at Giza, and notice that I had north over to the right and west to the top of the page and south to the left and east to the bottom, that orientation. And the reason we're going to view it like that is because the path of the sun is from the east to the west.
Okay.
So this is how this was laid out.
This is also kind of the way Orion's belt looks often in the sky.
Yes, exactly. All right. So when this QuickBird satellite image that I obtained in 2006 was really key to me breaking through with this whole model, because I had an idea, this mathematical model, and it was not agreeing with some of the survey data exactly, but only off by small amounts, and the amounts, the numbers of the amounts that the positions were off from this model that I was predicting were very curious numbers, that they were part of this template. There were numbers. So when I got the satellite image in 2006 and overlaid the mathematical model on this image, that is, and I have quoted from the satellite imaging person, actually there's two different people quoted in my book, that state that the accuracy of this image is anywhere from 4 to 10 inches. And what we're looking at there is about over a mile in diameter area there.
Okay.
And so
are you talking about the accuracy of the north, south, east, west alignments there to the image?
Oh, the accuracy of the image to what's true on the ground, like a surveying quality image.
Okay.
So
yes.
the surveyors can use this image here, this high quality resolution, high resolution image, to literally plot surveys. Actually, this very image was actually used to model the 3D Giza site for the Egyptian government, I do believe, at one point. Okay, the same image.
You're showing us a lower resolution version of a very high surveying quality image.
I did buy the actual image, though, so I do somewhere. Well, actually, I don't know that I have the whole original file again. I probably have to purchase it again, but
you got the original, yeah.
Now, so anyhow, this thing is accurate to 4 to 10 inches as we're looking at it, and we're looking at structures that are 750 feet long here, so that's pretty accurate.
Yeah.
Okay, I got you.
Image to lay our model out against. So to take a look at this, let me back up here. You see the center point of this complex where I had envisioned it. That's where, as like a craftsman and an artisan looking at balance, like as in a furniture aspect, like I was looking, you could see how drawers diminish on a beautifully designed chest of drawers, how you have a larger drawer on the bottom, and so that's why I tend to always look at Giza from this perspective. Okay. If you look at it as north being up, it looks kind of out of balance. It looks like, you got the heavy part on top and the little one on the bottom, and it doesn't look balanced from a design standpoint. So anyhow, that center is what I predicted, and it was half the distance of the base length of Khafra here to the center point. So half of that.
Okay, I see. Yeah.
Okay, so I'll show it a lot clearer here in just a second. So we'll just take a quick look. So from the center here, I was planting my hypothesis was planting the center right there, looking due west, and we see Khafra. So we're going to do a 360-degree panorama here to get a little familiar with the template and how it lays out at Giza.
All right.
So now we just turned 45 degrees, and we're looking kind of northwest, and we can now see Khufu, the Great Pyramid over there. And we can see that north line runs it's not on the actual edge of the pyramid. It's up a little toward the west of that. You can see a little better there. Now it's looking due north. There's Khufu.
Is that maybe running along where the original casing stones would have been, or the bottom of the socle, or is it?
Yes, I think it's right in one of the furthest measurements out. It probably is, but I'll show you exactly how they place the Great Pyramid off of that center line.
All right,
it's beautifully done, and it involves the creation of the sacred cubit of 21 or 5.1 inches. It's really beautiful.
Wow, cool.
That comes off of two different measurements to Khufu, because as we're looking down that north line there, as we can see, if you're looking down the edge of Khufu, there's a 3 feet difference at the center of the pyramid than there is from the two corners. It's inset 3 feet in the center, and you can see it in some that there's an indentation in the center of the pyramid of 3 feet.
Yeah, it's actually 8-sided or something, right?
Right. So at the center there, it's a different angle than it is at the outside corner.
Oh, yeah.
And that's why there's always a little bit of conflict on the like the measuring of the stones. Well, if you really get down to it, look at the geometry of it. If you were to lay a big plate on the side of that pyramid so that it really just touched the outside corners, that's one angle. And then if you laid an angle on the center, that would be a steeper angle because you're moving the bottom in.
Yeah.
So you have a steeper angle.
Right.
So anyhow, we'll get a lot more detail into that, but so we'll keep going here. There's these 3 satellite pyramids here east of Khufu that are really a dominant feature in how this template will fit together, and you'll see how that comes up later.
Yeah. So now you've turned us northeast.
Yes.
Okay. Now
we're looking. Yes, we're looking northeast now. It's like 45 degrees. Now we're going to turn another 45 degrees, and we're going to look due east now, and you can see the Sphinx down there.
Oh yeah.
And another thing I want to bring up here too, I also have in this model the elevations of the pyramids and the Sphinx from sea level, or how they differ in their elevation heights. And
at the base or at the
center pyramid would be placed at 0, the highest one. The next down low, according to my model, is 17 feet down. Below that is Menkaure, the third and smallest of the 3 main pyramids. And then the Great Pyramid is 33 feet below the elevation of Khafre.
Where's my bell? And
the Sphinx, in my model, I can't say I've got exact numbers from any scientific data, but in my model, it's 153 feet below.
Below 0?
Yeah, below 0, where the Sphinx is, the level of the Sphinx. So elevation's all part of this plan too, because what we're going to do is we're going to be literally recreating Giza just from a mathematical model.
Okay.
Okay, now we'll turn another 45 degrees, and we can see, it's a little hard to see here, but there's the Wall of the Crow. It's to the southeast of the Sphinx. That's a very important feature, as well as Kenkawais. That's another temple that is to the southeast there as well. And we'll keep turning here. We can see Kenkawais there, and now we're looking at the causeway of Menkaure that leads up to the pyramid of Menkaure in the southwest, the third and smallest of the 3 main pyramids, along with its 3 satellite pyramids. And man, I can't wait to show you the geometry in those little guys. It's amazing. So there we are. We just did the 360. We're looking back at Khafre. So that's how the template is laid out from that center point. And we can see there.
Oh, yeah.
Okay. So this is essentially the features that were going to be part of our plan here. And we're looking at the Great Pyramid, Khufu, the 3 satellites, Khafre in the center, and Menkaure up in the top left, and their 3 pyramids, as well as Kenkawais, and of course the causeways to each of these pyramids. The Great Pyramid causeway in blue here, and the causeway to the Sphinx. We'll show you exactly how all these are created, and why they were put in this position. So we're going to start off with this plan, and we're going to go from a center point and get this plane going. So what I'd realized, I don't know if it was in Schwaller Lubitz, I think I saw this originally, but the Egyptians had this mathematical or geometrical model here to calculate the area of a circle using this method. And that's where you would take the radius of a circle that is 9 units in length, take 8 of those units and square it, and you'll come up with the approximate area of the circle.
Huh.
So wow. If we look at this and do the math, now one of the things I know somebody had pointed this out to me, the pi that we're using is 3.14257, I believe. And that is actually the fraction of 22 sevenths. That's quite familiar in Egyptian mathematics, is the 22 sevenths, a fraction. So that's what we're going to be using in this, and you'll see why when it comes to the angle of the Great Pyramid. We'll be able to see all that. But anyhow, this template of 8 and 9 was always seen in ancient land management, and it was really a concept of the survey plat that they used. Well, here at Giza for one, but in other cultures as well. This is very similar things here. But so we're seeing how we would take a circle and a square, and we would by creating this 8 by 8 square, we are able to approximate the area of this circle quite easily. So for me, in my woodworking, we use board feet, and you're looking at a log or something, and you want to figure out how many board feet are in there. This is a beautiful way, and one of the ways that I kind of developed and caught on to this early was it allowed me to calculate things in my work.
All right. That's awesome. Man, we're ready for take a break. So
sure. Break, we can do that.
This is fascinating stuff. We'll take a quick break and we'll come right back into it.
Sounds good.
Back, ladies and gentlemen, Brothers of the Serpent podcast, and we've got Ed Nightingale with us going through a slideshow he's put together, and this is all about pyramids, folks.
That's right.
One of our favorite subjects of all time. And just for those of you listening, the latest slide is a grid of 9 squares on a side and a circle inside that grid that matches the diameter of 9, and then of course a square inside of that is 8 of those squares, and that is the area of the circle. Basically, it's rounded up. It's from 63.6428 rounded up to 64.
Very close.
Very, very close. So that's really cool, man. It's a very simple way of squaring the circle.
Yeah, isn't it? And you know that term we've heard before. So I think this is something to really look at and wait till you see where this goes. So what we're going to do is start doing analytical geometry now. So we got some geometry of a circle and a square, and so so what can we do with a circle and a square? Well, we can divide it in proportions or portions and start developing it from there. But we're going to take it into an analytical geometry, which would be adding numbers to this square. So in Plato, in his book Timaeus, he wrote about God's creation and how it was created by God using this lambda sequence. So Plato states that God created the cosmic soul using two mathematical sequences. One, a doubling progression, 1, 2, 4, 8, and one, a tripling progression, 1, 3, 9, 27. And he placed these numbers on an inverted V in the shape of the 11th letter of the Greek alphabet, which is lambda. And he says now, he continues, he says, Plato, quoted here, now God did not make the soul after the body, although we are speaking of them in this order. For having brought them together, he would never have allowed that the elder should be ruled by the younger. So, what is he talking about there? We got to kind of look into that. So he continues by saying, after this, he filled up the double and triple intervals, cutting off yet other portions and placing them in the mixture. So if we analyze what he's saying here, is he's saying that the elder, he would never have allowed the elder to be ruled by the younger. So if we look at that as the 2 and the 3 being the two, of course, different aspects here, we can actually equate that as a male and a female. And the one being the ultimate combination of the 2 and the 3. So I think what he's talking about is he would never allow these two numbers to be have a different value, let's say. So I got a couple of little notes in here. Albert Einstein once said, everything should be made as simple as possible, but no simpler. Is the 11th letter of the Greek alphabet. The lambda also in cartography and navigation, lambda denotes longitude.
Okay.
So lambda and longitude in cartography, and in the 11th letter of the Greek alphabet. And in astrophysics, the lambda represents the likelihood that a small body will encounter a planet or dwarf planet, leading to a deflection of a significant magnitude. An object with a large lambda value is expected to clear its neighborhood, satisfying the current definition of a planet. So that's what lambda is in astrophysics. And in particle physics, the lambda is a type of subatomic particle. So this is what Plato was referring us to as the lambda in this sequence. So now if we take Plato's lambda sequence, this doubling sequence and the tripling sequence, and we apply it to our 8x8 grid, our square here, and we go 7 intervals down our scale here, because we've laid it out now on the left-hand column of this 8x8 square. We're going to number it. And we're going to start with 1 in the top left corner, and we're going to do a doubling sequence down the left side. So it's 2, 4, 8, 16, 32, 64, 128, and 256 at the bottom of the 8x8 square there, those numbers. Across the top, it'll be 1 to the far left top corner, and then goes to 3, 9, 27, 81, 243, 729, and 2187. So each time it increases by 3 or multiplies by 3. But what we're doing in this coordinate system, and we're going what Plato was talking about here as the elder and the younger, we're going to apply the equal space within this square, and we're going to give each number, the 2 and the 3, the same base length, or the same length on its. So each unit of 3 is the same length as each unit of 2. So therefore equalizing the space between the 2 and the 3. It's kind of compromising these two numbers and giving them equal space.
Yeah, the grid's even though the grid is even though the numbers are different, right?
Right, correct.
Okay.
So how they got around those numbers being different and of different value, they gave them equal space on this grid. So it would equal out. And what that does is, as we look down here, we're going to go 7 units down on the left side, and we're going to go 7 units across on the top, and 7 intervals on a 45-degree angle up that scale. So as we see, we got 7 by 7 by 7 on these intervals, making up this coordinate, these points on the coordinate graph here. And if you go up each interval, going from one interval up on the angle, has a value. Each time it goes up 1.5 in its value. If you look here, we got 128 at the bottom left. And if we go up one interval and like a scale to 192, that's multiplied by 1.5. And if we multiply that by 1.5, we get 288. Multiply that by 1.5, etc. And that's the coordinates or on the scale. And you can see at the where
I don't understand how do you get, where does the 1.5 come from?
Okay, if we let's say if you multiply 288 multiplied by 1.5,
right,
that's like a fifth interval in music.
Yes,
is multiplied by 1.5. So this is what we're looking at, and actually you can understand this as a Hertz scale.
Yeah, I was thinking that this, like the 432 right there is A.
And the reason this 432 is key to this whole thing here. And what's interesting about that is, let's look at its position and its coordinate. 432, if we go 4 intervals down the left side of our triangle there, and we go 3 across, we end up at a coordinate of 432. So it's 16 multiplied by 27 is 432. And what that does there as well, so we got 4 on one side, 3 on another, and that also gives us 5 on the angle. So it's a 3, 4, 5 Pythagorean triangle.
Right. So the 1.5 is emergent from multiplying the numbers at the edges of the graph with each other.
Correct.
Okay.
This is a graph. You can multiply, if you take any number on your left column or your across the top and multiply it down where its coordinates intersect, that's the number value.
Right, I got it.
That is, okay?
I'm a little slow. Sorry.
Of analytical geometry, basically. So We're looking at this, and you can even think of it as time over distance, or measuring a vibration, or the Hertz. It's a Hertz scale is what it is. Comes right down to it. And if you can imagine, the top left corner would be 1 Hertz.
Right.
And 432 would be down here at
4 down and 3 over.
On the Pythagorean triangle.
That's amazing.
And let's also look at that a little bit closer there too. If we go straight up from 288, we got 144, and that's going to play a big part in this as well. Here we can see the Pythagorean 3, 4, 5 triangle where it intersects on the 432. And what's interesting here to note, and is a major point, we're not going to get too deep into it right now, but if you square 432, you get 186,624, which is very close to the speed of light.
In miles per,
So
per second.
432 squared. Okay. Well, what happens if you square that number? The speed of light. That's E equals mc squared.
Yeah.
C squared is the speed of light squared. So the important point to note here is, the speed of light and how that's developed out of this 432 and a squaring of it. And
what you're showing here on the graph is that you just take that right triangle, and the angle, the hypotenuse of the triangle is at the 51.13 degrees, which is the angle of the pyramid.
Of the Khafre
pyramid.
Yeah.
That's correct.
That's awesome.
This is a Khafre pyramid angle. That's right. We just created just what we did there. We just gave us, this is the reason for the angle of the pyramid of Khafre. And we're going to get into exactly how we create the base length of Khafre and how that relates to the longitude in the lambda.
Wow.
So yes, right now, the very, very observant there. Yes, it's we just created by the 3, 4, 5 Pythagorean triangle the angle of Khafre at 51.13 degrees.
And following that same line down to the bottom of the graph, you're saying that gives you the 186,624 at that that point.
You know, I might be wrong here too on that angle. I think I mistyped that. I think it's 53.13.
Oh, okay.
Pretty sure it is. Yes, it's 53.13. So sorry.
No worries.
There's a whole lot of angles.
The
going
angle
on
on the
here,
right,
and I probably
the
just,
angle in the graph is correct, but the angle in the typing is wrong.
Correct. Yeah, it's 50.13, I believe. So, okay. So anyhow, we can see there how that 432 and again, that angle, imagine energy flowing. We've got two different energies mixing, a male and a female, or a positive and a negative, right? And they one has a slightly different value because this, in my estimate, this theory of equal action, reaction for every action, it's, I think that would end up, if it was equal, it would be a static situation. So I think this difference between a circle and a square being slightly, the two energies that work together, I don't think can be perfectly equal, because it would be, if you imagine that they're working against each other, it would be static. You'd be going nowhere. It'd be like a tug of war that you would be both equal and you wouldn't be able to move ahead.
Yeah, there's all these subtle imperfections when you look at the universe. You try, there's no perfect circles, and it's, there's all these weird, just the deeper you go into it, there's always some slight imperfection to the math that you want to be perfect that's on paper.
Yeah, and that's a perfect way to state this. And what I'll show you here, these numbers that we're talking about in this coordinate system they're called Platonic numbers, or natural numbers. And that these numbers, if you can imagine, let's just try to make an analogy here of the Pythagorean triangle. Okay, imagine if we were energy, and that in order to flow, each unit had to be equal to go around that triangle. Could you imagine if they would only be able to cycle around those units? It would be like in a bicycle chain. Imagine that the only way that they would be able to cycle around that easily would be as if that there would be an equal units on each leg of that triangle.
Right.
That would allow everything to move around like a chain.
Right. Because the bicycle chain has specific units, and it would, in order to put those sprockets in there with the teeth in the right places, it would all have to be equal down to some, number that each side is divisible by.
Correct. Because one unit, if it was a different angle there, it wouldn't be able to flip around a corner to keep moving around. It would be,
Get
be like
jammed up.
a mismatched bicycle chain and spoke or a sprocket. Yeah. So anyhow, I think that that's how this energy is allowed to flow in nature, is that it uses that mathematical formula right there to allow energy to flow. Okay. So, okay. And imagine that these numbers now will have to let me go ahead here and just show you. Okay. Right down here now, if we go down to the bottom left-hand corner of that 8x8 square, and we draw a line up on a 45-degree angle, and we look at those fifth intervals, that's very much like 256 hertz is a middle C on a piano, right?
Okay.
Whoops, sorry. So we can see that that's how this musical scale is done. But if we know in music, a perfect fifth, if you were to just continually play notes that were a perfect fifth, it would soon be out of tune.
Yeah.
You need to adjust the tuning slightly to compensate. So it's no longer 1.5 perfectly. It's like 1.4, I don't know, 4.7, something like that.
Right.
In order to keep things in tune. So
yeah, in all keys. That's a really strange thing to me. It always has been. Like you look at, piano tuners have to deal with this because you want the piano to be able to play in harmony in every key on the scale.
All the octaves, yeah.
And so they have to tune it by the circle of fifths, but then they slightly detune as they're working around the circle of fifths by certain degrees, which are called beats, which you're really detecting with you're timing them and listening to how they're out of tune and how the two notes being slightly out of tune gives you this weird slow resonance. And
Yes.
there's like ways to do this, and some people have their way of doing it. Other people have other ways to do it. That's always been a really strange thing to me, how that works.
yeah, it always confused me a little in music too. I still really, don't completely understand it. But what I do understand, just on a basic concept level, and that's all that we really need to understand, is that these numbers in this coordinate system or this lambda sequence here they are the perfect numbers.
Right.
That nature is slightly off of this perfect numbering coordinate system. It's slightly off of that, and we need to adjust. So just like the tunings, we're also going to find that we adjust the measure as well, and time as well, and the calendars. We're going to be adjusting those slightly too by certain fractions, and I'll get to that coming up here. But we'll continue on here. And now I'm going to show you the circle and the square and the red 8x8 square within there. And now we're going to, I'm kind of jumping ahead here a little bit, but we could have gotten a lot deeper into that. But we're going to use the numbers in our coordinates there are 432 and the 288. We're going to use those numbers to place the pyramids on the plan now.
Okay.
I'm kind of jumping ahead here, but
that's all right.
So we can see we got Khafra, the pyramid that we got the angle of the Pythagorean triangle. We're going to set that right dead center in the sixth unit up from the bottom, and that will be 1 unit of our 9 units, and it'll be in a sixth position up. And we also, which is significant, is that the coordinate on it would be the southeastern corner or bottom left corner of the center pyramid as you're looking at it. That coordinate number is also 432 on a coordinate system. So we're going to place, that's how we're going to place that pyramid of Khafra. Then to the north, we're going to place a pyramid of Khufu, and we're going to place Khufu using the 432 feet from the northern face of Khafra north. We're going to travel 432 feet, but that would be measured at the center line of Khufu, which is 3 feet different than the corner. So it'd be 429 feet if you measured it up from the outside corner of Khufu, as opposed to the 3 feet difference that's the center of Khufu.
Okay.
So 432 feet to the center. And then we're going to use the 288 feet. We're going to do from the western face of Khafra, 288 feet will be where Menkara is. The bottom, it would be the bottom right corner as we look at it of the third smaller pyramid would be 288 feet west of the face of Khafra. There's a whole host of stuff. It's all in my book there's a lot more to this, how each pyramid in great detail, their measurements, angles, how they're all arrived is there. So we're kind of scooting through this a little bit, but hopefully it's clear enough to give us a start here, and then maybe we can go back at some point and go over any points that we need to clarify.
All right.
Back up. The other significant point here I want to get to is we talked about the 3 satellite pyramids for Khufu.
Yep.
They would be toward the east of Khufu, and their job in this template, in this architectural drawing that we're doing here, are going to alert us to the fact that one of our next steps here is going to be divide the circle. Now we're going to focus, we're on the square here, but now it's just going to throw some light on our circle. And the pyramid that would be furthest south would divide, if we drew a line from that pyramid through the center of the circle, it would point to a division of 11 of our circle. And the next pyramid north of that one, of the 3, that would point to the angle which divides the circle by 9. And then the northernmost pyramid, the third of the 3 small satellite pyramids, divides the circle by 8.
How are these dividing the circle?
If you just take a line, what I was doing now is also to understand this. When I was figuring this all out, I was reverse engineering. I was trying to understand why these pyramids were where they were, and when I put a ruler on each one of these pyramids, and I put the other end of the ruler on the center line, what happened was I ended up dividing the circle 3 different times, one by 8 divisions, one by 9 divisions, and one by 11 divisions. So these measurements of these pyramids were put there specifically to tell us to look at the division of the circle.
Okay, so what measurement of the circle is being divided? I guess that's my question. Is it the circumference?
Okay, if we take this circle and we make a 0 to the west as our circle.
Oh,
and
you're
if
talking
we
about the angle.
Oh, okay.
Pardon?
The angle from 0.
Okay, yes. West would be our
Gotcha.
0.
So you're dividing the circumference of the circle by 11, 9,
Right.
or 8.
Right. Both.
Gotcha.
Each one, and they were kind of color coded, I guess, but the blue and the red and the white. So we have the one pyramid, when you, and it really gets into exquisite detail too. They're not just arbitrarily in these pyramids. It's broken down into fine detail, which is all in my book. But when you just put a ruler on that pyramid and draw through what I was predicting to be the center line or center point of the circle, it was dividing that circle where that ruler intersected the circle. It was 1/11th of that circle if I were to have a zero to the west.
Yeah, 1/11th of its circumference, right?
Correct. 1/11th of its circumference.
All right,
Very
got it.
accurate there, yes. So that's a function of those three pyramids. There's the other three pyramids we could get into, but it's a lot more covered in my book. We won't get too deep into that. But for right now, you need to understand that these placements of these three pyramids were to divide the circle, show us how divisions of the circle, these in specifically 8, 9, and 11.
All right.
And there'll be more as well that other things will point out, as you'll see. Okay, so this is kind of a fast forward a little bit here, that this is in my book, and this is all the measurements I was mentioning to you about earlier when we were talking about the idea of Giza being this puzzle, and in some ways not unlike the Rubik's Cube, where if you have all the sides in the right, or all the blocks in the right position, you get all the sides match with color, and it works. But if you were to take one block and turn it, nothing, you're no longer have this perfect model. Well, these numbers, again, we're not going to get too much into it here tonight, but all these numbers are beautifully harmonious and show how the sacred cubit is created, and how they're using different dimensions. Like we mentioned that it's 432 feet to the center point of the Great Pyramid, how we placed it, but it's also 429 feet to the corner. But then we have another dimension in this same drawing here that there's a number of 429 royal cubits. So they're mixing cubits and feet together, and it's beautifully harmonious.
Yeah, I see. So like in some cases it's 432 feet, but then somewhere else it's 432 royal cubits.
Correct.
Yeah, okay.
Correct. And it's so beautiful. And if you really look at this, I'd encourage anybody, if you really just want to study, it's kind of an architectural drawing. And in the yellow, mainly I think it's in yellow, some of it's in purple, but I tried to highlight just how the length of those yellow bars are. I had the lengths of these dimensions written in there. And if you just look around, you can see that, oh my God, there's 429 royal cubits there, 429 feet there, and how these sacred cubits are made up by using the two different measurements between that measure the corner of the Great Pyramid as opposed to the center point of the Great Pyramid. It's really, I'd really like to get into more detail, and we will at some point. But
yeah, lots of processional numbers in there.
Yep.
Yeah, exactly. You'll see them all over, and it'll get even wilder as we go here. But
that's amazing.
So moving ahead here, this data all agrees with the satellite. By the way, of course, this was done with scale drawing overlaid on an accurate satellite image that is documented as being accurate to within 4 inches or half a pixel is what they were telling me. They said it's so accurate that the only inaccuracy is the problem with the pixel size, and the pixel size was 4 inches.
Yeah, 4 inches per pixel. That's
yeah.
Yeah.
So that's how accurate this is. And in my book, I also go into comparing the satellite image with Petrie, and I can demonstrate how if you were to take that same satellite image and overlay Petrie's data, you'll find that it does not agree with the satellite image. And there's differences. For instance, in I think it's in Mankara, the third and smallest pyramid at the top left corner, it would actually be, I think in Petrie's data, I think it's either 27 or 33 feet. I can't recall right off the top of my head without my notes. That it's to the east compared to the satellite data. So that one's off. I think it's 33, but
it was probably his assistant Johnson put the stake in the wrong place, when he was trying to set up the instrument.
So the interesting thing, and what I really get into there in the book, and I challenge, I say, okay, well, I got a satellite data that says it's accurate to within 4 inches, but when I put Petrie's data in there, why am I off 27 feet on that pyramid, and then 9 feet on the Great Pyramid? Which is very interesting because both of these numbers, whether it's 27 or 33, either one is significant within this model.
Right.
And 9 is very significant in the fact that our whole template is made up of 9 units.
Yeah.
So, anyhow, that's in the book. You can look at that. And I'd really, like to get more into, diving deeper into that a little bit and getting some more data. But I really think that this model, again, the coincidences here, as again, you look at these numbers, I want you to remember that what I said in the beginning, you're going to have to, as I keep showing you these different things, you're going to have to make a decision on your own, and you're going to have to classify these bits of information as either coincidence or, it's really a part of a major plan or puzzle here.
Yeah. So we're coming up on another break here. I got one last question here. I'm looking at this image. I see you got a Fibonacci spiral coming out of the Sphinx. Where is the origin point there on the Sphinx for that spiral?
I'm going to show you that coming right up here, and it's beautiful how the divisions of a circle work with this spiral, and we're going to get into that right after this break.
All right. Stay tuned, folks. Be right back. And we are back, ladies and gentlemen, Brothers of the Serpent podcast with Ed Nightingale, taking us through some geometry of Giza and the Giza Template and all of his work on all this interesting and ancient symbolic math. So, Ed, where were we going? We were talking about the spiral and the Sphinx.
Yeah, okay. We were talking about the template and how we're going to be bringing in the spiral into this. But first, we'll start out with the template. And there's really two celestial aspects of Giza, and that is one of the Orion correlation theory by Robert Bauval, who took note that the 3 belt stars in Orion align with the 3 pyramids at Giza. And I can definitely confirm that through my research that is indeed the fact of the matter, and you'll see as we develop this model further. So the 3 pyramids are representing Orion, and if we were to, we'll get into showing how these will align on Orion. We'll do an overlay looking at the plan view, and we'll view that. But this one aspect of Giza is Orion. So we'll look at Orion, and there's a picture of Orion, and we can see Barnard's loop there as well. That spiral that churns into it'd be Orion's sword, down in Orion's sword, the M42 nebula, a great Orion nebula, where that the spiral is emanating from that, and that is what they called Orion's chariot. He's riding in this chariot, and as you can see from the diagram there, we can see that they made the asterism for Orion. Now, asterism are the drawing, that the imaginary drawing that they created using different stars as just points that they chose to try to depict in the sky a story. What they're doing is telling a story. And in the sky, using these asterisms and alignments and how they relate to the trajectory of our sun and how that relates to our right down into the solar system and our view from it. So we're going to be tracking in the sky these different constellations, and we'll be looking closer at Orion. But that's the one aspect. The second aspect at Giza celestially, first here we'll look and see the three belt stars are Alnitak and Alnilam and Mintaka. Then they represent, and that's how that they align properly with the Orion correlation theory on Orion, and that's a scaled model to it right there. So the next celestial aspect is the Sphinx, and that is really, I believe, originated as a lion, and I believe that the head was probably recarved in later times because this is much more ancient than the 3000
the pharaonic
BC
Egypt
date given. And Schock and Dr. Robert Schock, geologist and great guy, he was very correct in his water erosion theory and how it's dated back. And I think it's probably going to go back even further than he dares to think too, which is not unlike the view of John Anthony West, where he thought it went back even to this time of Zep Tepi, or the first time, as the Egyptians call it, back at the beginning of the King's List, which is about 36,000 years. I know, which is a very astounding number, and I know it pushes things back a lot deeper than a lot of people are comfortable with, but we've got to at least consider it, and that's what they say, and I think it needs to be considered at least. But we'll look for evidence as we get further into this. Is there something to this 36,000 years of Zep Tepi, and is there any significant astronomical alignments geometrically that occur somewhere in that cycle that might clue us in? So we're looking at the Sphinx, and that representation in the sky is Leo, and it's star Regulus. And I want to put a little note in here too, that as we look at the names of, I could even back up to, let's go back to Orion to start with. I know this is probably going to be very controversial too, and I don't know that I can even prove it. All I'm going to do is point it out, and you can either put it in the category of is it a coincidence, or is this actually correct, and this is what they were trying to refer to. But my point of Orion, the word Orion and the word origin and the word orient all seem to me to have a common base there, and if we can imagine for our model here, we're going to use the name Orion is going to hopefully point us in the direction of origin and orient and Orion. For our model, that's how we're going to use. And like I said, you can put that wherever you want. If it is what it is, and I'm just saying that there could be an association there.
Yeah, I
now,
see it.
okay, so now the same thing is going to go for Regulus, the star in the chest of the Sphinx. Now, there's another star that can go out, would be a pause, but the star Regulus there is at the chest of the Sphinx. And I want the lion on Leo, which if we were to translate that to the Sphinx, that position would be right where the dream stela is. Okay, or right, right
between the paws.
Where the
basically.
dream stela is, Regulus, right between the paws. So
Regulate.
Yes, exactly. You got it. So I'm saying regulate because Regulus is on our ecliptic, and it stays on the ecliptic as the zodiac constellations process. We can see Leo. Will go around and make this circle. It will complete a circle of our pole. In the pole will rotate in 24,500 years or so, but Regulus takes much longer to rotate. But you can actually see Regulus will precess too, and takes from the galactic alignment in 2012 to the time when Regulus was helically rising. In other words, when Regulus came right up, I'm sorry about that, right up at the same time the star Regulus at sunrise. So when sunrise happened at the Sphinx, we're viewing the sky, sunrise at the same time Regulus is on the horizon. That would go around and take, I forget exactly how many years it takes to do a full circle, but from the galactic alignment in 2012, it was about 36,000 years. So Regulus regulates the zodiac, the ecliptic, and we'll watch that Regulus go around just like a clock will go around that ecliptic. Just as the whole Leo constellation will move around the zodiac circle.
Wow, I never thought about that. So these stars, because they're also moving at different rates. Like I've always thought of the precession of the equinoxes as like these, on the spring equinox, these constellations are rising up behind the sun, and they're moving around. But each individual star is also moving around independently from the constellation itself, and so the actual heliacal rising of one particular star could take a much longer cycle to rise behind the sun. That's really interesting. Never thought of that.
Yeah. So Regulus now, if we'll get into this later on in very good detail here, you'll see that Regulus, when that's helically rising, it's 36,460 BC. So that's right about the time of the tepi and the King's List. And you'll see that Sirius was on helically rising at the same time. And Orion was also on helically rising at the same time. So it's a very unique alignment that would lend credence to possibility of at least the plan or the base layout of the Giza Plateau was the original plan was started then, and very well could have been built in stages.
So those other constellations were heliacally rising, what at the solstices or something? At different.
It's winter solstice or the winter, December 21st in the winter. So,
Okay. Solstice. Yeah, that would be the galactic alignment too, right?
Yes. And that's the key. This is the key to this whole clock work. And we'll be getting into that. I'll show you exactly how that all will work.
Okay.
But the images that I'll be using are on a specific date. And that specific date is December 21st, 2012 at this galactic alignment.
Okay.
So you can imagine if we're going to be mapping our trajectory and trying to make heads or tails of, how we're moving. And so we set up spots to monitor this motion. Our spot to monitor this motion is going to be right there at Regulus, looking at the horizon through this lion. So this duality of the dual lions on the dream stela, in my personal opinion, this is the second Sphinx right here, or second lion.
Oh,
right.
That makes sense. They're looking at each other.
Yeah.
Yes.
So you got the one below. That's just one in stone, and the one above. That's the one in the lion of Leo.
So simple.
And the Regulus, the regulator is going to be this period of time that Regulus takes to circle to make its loop around from the next time it helically rises after the 36,000 BC number. So we'll be seeing how that all works. So again, Regulus is our regulator, and Orion is our orientation. That's where we're oriented, or we need to look for our origins.
Awesome.
All right.
Okay, so the next thing we're going to, again, I'm jumping ahead here a little bit too, but I'm going to show you here, we're going to take our circle. We had a circle and a square with the 8 and 9, and we showed how the square of 8 is very equal in area to the circle of 9 of the same units. Now we're going to get into the spiral and the division of phi, or the Fibonacci. We also know it as a Fibonacci sequence. And we're going to show just how we can do that with using simple geometry. It's called the golden cut. And what we're going to do is we're going to create the angle of Khufu using this method. So we take an arc, and we swing an arc from the very top of the circle on the far west. It would be our western point on our map to the top of the page, and we would have another radius that we would swing from the bottom right, and we would do the radius and spin that up. And anyhow, these two lines, when they are tangent, create this angle. You can see it better just in the diagrams here. I know it's hard to do this on radio to explain all this, but a very simple geometric process here divides our square into a phi ratio and gives us this angle where it creates, using the circle, using the phi division cut, creates this angle of Khufu, a 51.84 degree angle. So you can see this is called the golden cut. And you can see how it divides our square into this phi ratio of the 1.1618 ratio.
Wow. I did not know you could do that. That's really cool. You guys, I just want to say for people listening, you really need to watch this video. Yeah. If you really want to get this. The stuff that he's showing is very simple to look at, but it's very difficult to explain with words. So just basically, I struggled with that from the beginning. So it is a very visual thing, and I hope everybody can. Basically, you take a compass and you make two simple curves inside this square and then bam, you've got. It's very easy to do, you can see. And now you've got the phi ratio. That's awesome. So this phi ratio, we can see that in our physical makeup, and if we look at our arm, and from our elbow to our wrist would be 1 unit, and then from our wrist to our fingertip would be 0.618 units. So nature uses this. You look at sunflowers and the spirals and anything in nature, how branches will branch off in Fibonacci sequences or these phi, and we'll show you
how similar the Fibonacci sequence is to the phi ratio in a very interesting way. We won't get into that yet here tonight, but it's we'll show you how those two things are similar, as the Fibonacci series are all approximate this phi number, but do so at a very certain interval. We'll get back to that. But anyhow, right now with this simple 2 swings of my compass, I was able to create the angle of Khufu. And that angle is 51.84 degrees.
Wow.
So now we got the angle of Khafre already, the Pythagorean triangle. Now the Khufu,
the golden ratio,
51.84 using a golden cut.
The golden cut.
Now this golden cut, here we get into this where I was talking about the phi number that we used in the approximation of the circle in the beginning. Here's where we come up with this ratio. So this ratio of this pyramid of Khufu of 51.84 degree angle, if you were to break it down in units, the height of the pyramid would be 4 units in height. And if you're looking at a cross section or a triangle of this pyramid, the cross section, so half of the base length would then be 3.142857,
which is pi. Yeah, holy crap.
Pi or the 22/7.
Yeah.
That's freaking.
It's not exactly pi, but remember we talked about when we were talking about tunings.
Yeah.
Right? There's slight adjustment, right? These are the perfect numbers, but we got to slightly adjust those. And the nature.
Yeah. This is the 7.
The real ones are close to it. And there's even the method to show how that, using a proper fraction, that will come out to be correct phi.
Right. This is the divide by 7 repeating numbers, 14, 28, 57.
Right. Yeah. Exactly. The repeating. Exactly. You got it.
That's awesome.
So these are these beautiful, easy numbers that work and work well to divide and proportion things the way that nature does by using this equal area given the 2 and the 3, so that neither the 3 or the 2 is overpowering, but they're both working together with equal space and creating these an easy path for the energy to flow based on harmony.
Yeah.
And resonance between these certain numbers that happen at these coordinates.
So so basically what you're suggesting is when you're looking at this, even drawn on paper, and looking at the numbers and the harmony in the numbers by these simple ratios and fractions, that translates in the real world as the path of least resistance for energetic, like for vibration, for energy basically to move through the universe.
Exactly. Exactly.
That's awesome.
And again, we can't have this equal thing where if they were each given this unequal situation, we need to, we can't have static. We need one power to be slightly less than the other so that there's some kind of forward momentum.
Yeah, there's movement, right. Yeah.
That there's movement, yes. So there's there's where our pi comes from, and the 22/7. So again, just the most basic of geometric divisions, right there gives you the angle of the Great Pyramid and this connection to pi and a lot more to come.
Well, I'm going to have to complain to Randall because the way he told me to arrive at the golden section is much more difficult than that one.
Yeah.
But it's actually cool. Yeah. It's just a lot harder than that.
It's again too, we'll get into it where I'll show how that the square is divided up into a Fibonacci that most closely relates to this golden cut. It divides that square into 34.
What?
So there'd be a 34 by 34 square, and that would give us a line right there. It'd be there would be 21 units in the upper section in the square, and there would be 13 in the lower section in units.
Yep.
If that whole square was divided by 34.
Why is it called the Golden Cut? Where did that name come from?
I believe that's just like an architectural name. It goes way back. I really don't know the origins of it, to be honest. It's just known in design and drawing. Like,
well, section is kind of the same thing as cut.
Yeah.
You know.
Yeah.
Well, it's just a very simple way with a compass. And believe me, too, when I started this whole project, that's all I was using was a compass and just, a calculator or whatever and a straight edge.
Yep.
That was all I needed to do to figure this all out. So I know it sounds difficult, especially if you're just listening and you don't have the visuals, but it's actually beautifully simplistic. And you'll see as we carry this further. So let's move on ahead. So now we got the two angles of two of our main pyramids already. And now we're going to look at how that relates to our lineup of our three pyramids there and the spiral within that we just created using that golden section that we just did. So from that, where we divided our circle there to create the angle of Khufu, now sits right on top of the spiral. As you see, we can take that golden rectangle, which we created. That's what that's called, a golden rectangle you obtained from the golden cut. And then
you're starting to subdivide it into the Fibonacci sequence all the way down to the smallest squares.
Correct.
Yeah.
So we just go back, and where that falls, you'll see the intersection there of the diagonal of the golden, the golden rectangle on the top, and then also division on the other angle going from the bottom left corner up.
Yes.
And the center of that spiral. So what we're going to do now is we're going to, let's see, I think this is the next one. Let me just see here. Oh, okay. That square right there, which is at the center of that spiral, is, if we count from the bottom right corner of our 8x8 grid, where our information and coordinates are, if we count backwards from the bottom right, that's the 21st square. Okay. Also, if we were to count from the top left corner, it's the 44th square. So either counting from one direction, it's 21, counting from the opposite direction, it's 44. So that's going to become where we're going to be positioning the Sphinx within this block of 21. The 21st block. Now what we're going to do is we're going to divide our circle by 13. And we're going to also divide radial. Well, we'll do it radially, starting at the top. We'll going clockwise. We will divide our circle by 13. And at 7/13, we're gonna put an angle on 7/13 of that circle. We're going to use this angle for our the causeway from that originates at the beginning of where I said that center point would be on our plan. So this 7/13 represents the causeway to the Great Sphinx, and you'll see how that. We're making a model here, and then what we'll do in a little bit here is we're going to apply this model on top of this accurate satellite image and see if indeed this model matches what's on the ground.
Okay.
So what I'm saying now is that 7/13 is the Sphinx causeway. And then at 7/13 radially divided, in other words, if we divide that radius by 13, and we draw a circle at 7/13 concentrically, going from the outside in, and we'll put locate that right on that intersection of the 7/13 radial and then 7/13 concentric. We'll see what happens here. Again, that's going to fall into our 21st square, and it falls right into the center of that Fibonacci spiral in that X, or that cross in the middle.
Yeah.
Right on the Sphinx.
So what we're doing here, to try to explain what we're looking at here, we had done the square and the circle, and now we're doing this spiral, and we're seeing how this spiral fits into the the relationship of the spiral to the circle. And
Gotcha.
we saw that when we created the angle of the Great Pyramid, when we drew that line across the bottom at that golden cut, we intersected the circle. That's where we created that angle. So
Right.
we're seeing how that spiral, which is created by that line, where it intersects the circle. So that's what we're looking at, is how geometrically the spiral works with the number 13 and 7/13 of a division.
Right.
So 13, the proportions of a circle divided by 13 beautifully demonstrate a Fibonacci or phi division of this golden rectangle. Now, it sounds a little complicated to try to visualize here if you're not looking at it, but it's beautifully simplistic. It just shows how the circle divided by 13 relates to the spiral beautifully, harmonically, and geometrically.
Yeah, and specifically when you divide the circle like a pie into 13 parts, and then you divide it radially into 13 parts, and then you get that intersection. That's cool.
Right.
Yeah.
Right. Yeah. So that's what's going on here. So now, mind you, we're going to be putting our Sphinx in that. So what we're seeing here is this circle of the Regulus. We'll be putting Regulus on that that point, so we can see how the ecliptic goes. But let me go ahead and move ahead from that. Oh yeah, okay. That's also showing you that's the 44th square as well. It can be considered either these two numbers, 21 or 44, for that square that we are is at the center of the spiral diagonals, as well as the 7/13 concentric and radial points.
Is that where you're getting the 13 from? Is that?
Yeah.
Okay. Because 44 minus 21. Yeah. All right.
So now if we step this up a little bit more detail here, if we recall our Lambda sequence, and now you can see I put some numbers back up on our grid, and we're going to see where our 21st grid, where the Sphinx is going to be located. We can see that it's going to be in this square, and these squares have already been divided, right? So we know that this is in the 1, 2, 3, 4th square from the left to the right over, and it's the 3rd square up from the bottom. So where these units are divided, that would be in between the number at the top, it would be 27 and 81. So therefore, in between those two, there's 54 intervals or divisions between 27 and 81, right? You see that? Then down here, this, if we go to the top left corner and start at 1, this first square would have 3 divisions, right? 1 to 3.
Oh, yeah.
This next square over would be at 6 divisions, because it would be between from 3 to 9. And then likewise, each one of these intervals has more divisions because of the higher numbers.
Right.
You following that? So we got 54 divisions in the vertical coordinate there, and then there are 32 divisions in the horizontal grid. So we're gonna take this grid in that 21st square, and we're going to see its divisions. And that square is divided 54 vertically and 32 horizontally.
All right.
Yep.
And if you do the multiplication here, let's see, 54 multiplied 32 is 2,592. So the center of that square in the coordinates are 2,592.
Well, I'm getting. Well, hang on a second. I'm getting 1728. 54 times 32.
Oh, wait a minute. I think I did something. There is. That's
we're
right.
trying to figure out how many divisions total it is inside that square.
Right. It's not by 32. It's 48. The number at the center of that coordinate, halfway in between 32 and 64. Sorry, I mislabeled that. That should be
right. Between 32 and 64 is 48. Right.
Right. At the center of that, where that line, it'd be the midway point between 32 and 64 is 48. So that would be the coordinate. So it's 48 times 4.
48 times 54 is 2,592, which is one decimal off of the precessional cycle, 25,920.
Yeah.
Exactly. Okay, so now we need that got your attention, and anyone who understands precession recognizes that number right off the bat. So right off, we can see that the center of that square is pointing to precession in the great year. And
that is cool.
We'll get further into that. Let's look a little bit deeper now. We'll keep rolling.
Well, we're about to take a break, so we can contemplate on that and get back to it after the break.
Yeah, great.
And we are back. Brothers of the Serpent podcast. Snake Bros Institute for Advanced Coprolite Studies, where there are no degrees, only certificates of ignorance, which we are exhibiting today on how much we don't know about what's really going on.
That's right.
At the Giza complex. So this has been a really amazing journey. So, Ed, where are we going with this last segment?
All right. Yeah. Well, we'll kind of, like I said, we're going to break this down here and show you how this, the Sphinx and the Fibonacci spiral all works here, and how that relates to the great year. So, what we're looking at here is our square that the Sphinx is residing in, that center of that 21st or the 44th block in our coordinate system. And we can see a little closer here. We have the 2592 number value at the center of that square,
right,
which is a 48 multiplied by 54, arriving at that number. The number 32 there is the number of divisions within that square. And the center of that square value is actually 48, because 48 is halfway in between 32 and 64.
Right.
So just to clarify that, it's a little misleading on this slide. But so also, I actually want to point out here too that it's the 7/13 of our circle. That is our the causeway for the Sphinx that runs from the center of our circle, which is at the temple of Khafra, is at the center of that, and that has some very interesting proportions in it as well. But so what we're looking at here too now is if we go around that circle and divide that circle into 259.20 degrees, based on our 0 being at the north position or the right hand center of our circle, not the center, but the outside edge of our circle to the right as you're looking at it would be 0, and go counterclockwise around 259.2 degrees, and bingo, we're right at the intersection of the diagonal of the golden rectangle and the head of the Sphinx, right? So this number goes right through the head of the Sphinx. So there again, so its coordinate value is 2592. The angle that the Sphinx's head is 259.2, clearly showing the great year precessional cycle of 25,920.
There's
crazy. Even more to this too, but again, I'm not going to go too deep. I'm trying to just give you a little bit of an overview here, and maybe we'll take a couple minutes and show you where it's going. But
so I'd like to point out I'm not an expert at sacred geometry or just geometry in general, but I've played around with it a little bit and have talked to Randall about it, and just doodled on paper and stuff. And so it seems like what you're showing here, I mean, some people might say, well, you start drawing enough lines on paper, you can kind of make it do what you want. But these things that you're doing, dividing this grid, and how you get, the Fibonacci sequence, or you get the golden cut, and then you divide the golden section by these, the golden ratio rectangles diagonally, one of the larger rectangles and then one of the smaller rectangles diagonally, that center point there. These things are typical methods for working on layouts of geometry or sacred geometric principles. And so you're doing these things, and these intersections of these lines all have significant numbers, and the way the Giza layout is on the ground overlaid on these all fall in these intersections between these significant divisions. And I just think that is...
Yeah, it's fascinating.
It's fascinating. And like you said in the beginning, it's too many coincidences.
Too many coincidences. Yeah.
And we're only scratching the surface here too. Like I said, I could go into way more detail, but we'll do that later shows. I just want to try to basically give you the story here of Giza. And Giza is a repository, and it's got scientific knowledge, and it was left there to retrieve and times of where civilizations fall. This knowledge is still there, and someone with limited abilities, a compass in a square, can rebuild this knowledge if it were to get lost.
Right, but it's only, if you think about it, you think about what Petrie did, having gone on the ground out and started surveying it, that takes a pretty serious set of skills to be able to do that accurately. And he still made mistakes. And now we have modern technology looking at it with satellite imagery, which allows a technologically advanced society to look at an accurate layout and then apply these ancient principles to it and see how it's all, you know what I mean? It's yes, you can do this with simple tools.
Yes, exactly. And I want to reiterate that fact that how I started this whole thing out was literally with a compass and a straight edge, really. because I was able to find other ways to get square using the compass.
Right. But also you were like, in order to put that layout of actually like what's going on in Giza accurately on your paper required the space age technology of satellites and cameras.
To check it, right?
Yeah, to check it.
So you're right. You can perform these layout exercises with simple tools, but to extract it from the completed layout and confirm it, you need space technology. Like it's really interesting.
Yeah.
It's exactly how I verified it.
Yeah.
I obtained an accurate satellite image to within the testimony of the imagers were, 4 to 10 inches on the outside, 4 inches on the inside, and that was only due to pixel size.
Right.
But the orientation and accurately to that point is remarkable, really.
Right. And if, you imagine somebody like Petrie, who was very meticulous, and he's going around and he's surveying all this stuff, and he wasn't able to, he did a really good job, but as you pointed out, the satellite imagery shows that he made mistakes. And so you think about the people who originally laid out this plan to get it so accurate.
Yeah, it's
on the ground.
This changes everything, really. This just blows wide open any kind of doubt as to the high sophisticated knowledge that these people, whoever they were, that created and built this, and just the incredible. Again, I resort to the Rubik's Cube comparison to this. You can imagine that, these beautifully integrated numbers, how they work together. Who thought of that?
Right. That's the other thing, is like, what genius came up with this? It's just,
this is just mind-boggling to me. I'm sure I'm not the only one that feels this way after they see this and understand what I'm presenting here. Anybody can recreate what I'm doing. Any academic wants to, check me on all this. I don't say it's 1,000%. I've done the best I can, and all these numbers work. You can recreate what I've done, and I demonstrate all the methods in my book. And I've done different interviews and gone over more specific parts of this on different shows I've done,
and still, we're just barely scratching the surface. We're almost 2 hours in, and it's like,
yes, that's what my friend Randall, he teases me about having a curriculum, and it's true, and it's difficult in that there's so much information here, and it's so over the top that you just can't nonchalantly go out there and make these claims. You got to kind of back it up as you're moving along, and it all fits, and it can all be reproduced, and it all explains so much. You're gonna, once you get through this and everybody kind of grasps what's going on here, it's going to answer so many questions about so many different things, so many different topics, and architecture, art history is going to be. I did a show on Leonardo da Vinci's 500-year death. I did where I was able to use the Giza Template to show that Leonardo da Vinci, in all of his, I did 20 paintings. I showed how the map that we're going to be making and creating here as we move along is very precise and fingerprint-like. I know the story there you were just relating to, if you put enough lines on, something's going to line up. Well, no, that's not quite how this goes. You obviously need to follow it step by step, and you can see there's an exact reason for each one of these lines, and where they are is no accident. And it tells a very specific story linguistically as well as mathematically by the numbers. and we're making a model that is really harmonious here in the numbers. And we're going to take that and we're going to overlay on the satellite image. And you're going to see every aspect that we can recreate by the explained reasons that we're going through here, and how this creates this calendar and this information on how to read this calendar and how to measure and how to understand where we've come and the seasons. So we need to understand seasons, not only of the yearly seasons. That's really important to understand to survive, as well as the seasons of the great year. I did a show I have put together that shows how the great year cycle relates to climatic changes with certain alignments and stuff. So that's what we'll be getting into further down the line here as we decipher this puzzle.
That's awesome.
It's a map, and it's going to show us the trajectory of our sun from its birth and its path out the spiral arm of Orion. From its origin, it's the sun's origin, Sirius's origin, and the Pleiades' origin, coming out of the star-birthing nebula of Orion.
So, okay. What does that suggest then about the people who laid this stuff out on the ground and built it? I mean, what knowledge must they have possessed, not only to actually do the building, but also to have discovered the path of the sun through its birthplace to the point that it was at the time of the building of all of this. I mean, do we have that technology today to figure this out?
Well, I think that they've known it all along, and that's what I'll be presenting. And that's what's going to be so jaw-dropping on this whole thing, I think. And you're going to see how there is a lot more people that know about this than you would imagine. This has been kept secret and hidden, this understanding, but it's been known, by the church and the secret societies and the Knights Templars, and it's been carried on and passed on through verbal and teachings, direct verbal teachings and different writings in schools like, Plato's Academy is a perfect example. And Leonardo da Vinci, same thing. I think he had a quote over his door, about geometers only need enter. So these were schools, these learned men, Plato, Aristotle, all these guys were there's a great painting in the Vatican of the School of Athens, where it shows all these great, Plato and Aristotle and Pythagoras and all these guys in this painting at this, there's Plato's Academy as well, but also the School of Athens. These were great schools that passed this very knowledge that I'm talking about right here. They passed it on, and
they both protected it and transmitted it to the future.
Yes. And how they did that was doing it in the stone, but they also did it in the paintings, and they used this template in it's like a fingerprint. Again, this date of the great or the galactic alignment in December 21st, 2012. This alignment was, if you can imagine this clock now that we're beginning to create here, it's 0 hour or alignment, how we make sure that everything's aligned. And when we start the clock running to measure it and measure our trajectory, is this galactic alignment. When from the Earth's point of view, the sun rises, and directly behind it is the center of the galaxy. And the plane of the galaxy is almost parallel with the horizon. And so that's lining our clock up. And that's a key point in this whole thing too, is that the galactic alignment.
Very cool.
And how it relates to this great year. Everything is based from that date. And there's a reason even for that date. And we could, I don't know if I'll have time to really get into that part of it tonight here, but there's the causeway from the pyramid of Khufu, the Great Pyramid, actually is on an angle of 12.212012 degrees, where if you change that into a date, it would be 12/21/2012. So the angle of the causeway for the Great Pyramid is literally digitally marking a galactic alignment with a binary code, 2s and 1s.
Wow.
So, so they're incorporating multiple different calendars as well as multiple different measurement systems.
Because, well, the calendars are not necessarily different. They're different aspects that, when combined, all add up to, okay, we know that the 2012 is this galactic alignment, but when we go back to the calendar, let's say the year 0, well, you'll see when we're going to the next stages of this, we're going to sit at the pause of the Sphinx, or right there at the longitude of 3113.777 degrees, and we're going to monitor the sky, and we're going to use stellarium, and we're going to run the clock back, and we're going to, from that galactic alignment, and we're going to see when these starting on that very day, during the hours, we're going to start clicking the hours ahead and see where the sun was, and see where when Orion came up, and the different heights above the horizon. We'll be monitoring all that and seeing how the year 0 has everything to do with the position of the Pleiades, and the Pleiades is 90 degrees above when Sirius is on the horizon, 90 degrees straight above vertically is the Pleiades. So it's an alignment of the Pleiades at the year 0. And that also shows, like a 2012, if you would have put Sirius on the ground and looked at the Pleiades would be 11 degrees to the left of vertical. So you got 90 degrees up, but if you go 11, which would be 101 degrees, or 11 degrees to the left, it would align to Pleiades. And then over 2,000 years, the Pleiades moved 11 degrees. So that gets back into the 11.
Back into the divisions of the circle that we were talking about earlier with the 3 small pyramids.
Looking at the number 11 for us. So, let's see.
So,
all right, well.
I wanted to ask you, we've been talking about, how all of this stuff, this layout applies to these larger cycles, these astronomical things. But there were also hints of, the musical notes, the notes of the scale, and these are frequencies on a much smaller scale in terms of time. And of course, how that applies to energy and everything. So I wanted to ask you, just generally speaking, do you think this layout has answers in it to, some of the stuff we'd be studying in physics on a micro scale? Is this something fundamental to the universe itself, all of this stuff?
Absolutely. And this is the scientific knowledge that was left by whomever. We can maybe get to the bottom of that in this understanding of this. But we need to pay attention to what the Egyptians were saying. We need to understand about the first time, or the tepi, and the deeper cycles here. And what we're going to find is how this calendar, or how the stars were located at different points, and then again how the geometry of this trajectory, there's a geometric motion here that we're going to see that interacts with Sirius and the Pleiades, and that when these alignments occur, what I'm going to suggest here, and I think I can give quite a compelling argument, is that each of these star systems you can have a tail or filament that goes from the sun back to its place of birth. Likewise with the Pleiades star system, they're on this filament that this energy runs down in this natural. We got to understand that the universe is a little bit more of a plasma component in it, and although it's subtle, it's there.
It's vast too. It's
so what I'm going to suggest here too, and I'll even give you a demonstration on how the alignments, like in astrology, instead of the planets aligning, we're going to show where the pole and the sun and either the Pleiades align. So if you have an alignment of, as our pole goes around the sun, we can draw a straight line from our Earth into the sun, into either the Pleiades or Sirius, depending on the time as it goes around the circle. But these seem to coincide as we roll the clock back with the change in climate or climatic disruptions, might I say. So these spikes during the Younger Dryas seem to correlate with relationships geometrically aligning between these systems. So if we imagine these are filaments that are electrically there, how would you get from one place to another very easily without having any propulsion on board?
Riding the filaments?
You would ride a filament, and you could travel at the speed of light, and these filaments would only be in the neighborhood at certain times during this great year cycle. Because you can imagine, if we imagine our sun on a spiral path away from Orion, as well as Sirius and the Pleiades on their own spiral, just off of different degrees. Like if we take another spiral, just like the one we're looking at, and we rotate it, and if we rotate it 31.14 degrees, we get the next spiral, which will relate to the Pleiades, and that's why there's a 3114 BC marker there when all these geometric alignments align. So 3114 BC was relative to orient the spiral on the there was an alignment at that point in time that made this spiral perpendicular on the horizon on that date. It's really quite fascinating when you get to look at the Stellarian views of what I'm talking about here. I don't have them up now, but
so are we talking about an interstellar civilization, perhaps, that was doing this traveling, or was?
Let's face it. A lot of the myth. What do they tell us? They told us that teachers came down from the heavens and taught us things. And like at Edfu, the in the Builder's text there, it talks about. It says, roughly speaking here, it says the plans for the temples came down from the heavens in the days of Imhotep. So what I'm taking that as saying is that that's why I think there was different stages built here, because this cycle of time was so long, and to build structures the full cycle of the galactic alignment to get from one full cycle is 52,000 years or so. So I think that this first time was a time when they actually chose Giza as the place. And I think that they probably carved the Sphinx and some of the earlier features of I think they laid it out. Like if you're going to come in and build a big, a project like this, you would want to go in and start laying it out, just the foundational parts first.
Yep.
And that could be right in the bedrock, which a lot of it is. So, I think the overall plan was conceived in the beginning. So whatever, if the Sphinx was created, however old that is, that's how old this whole plan is. Maybe when it was executed, we can argue about these dates of when these pyramids were built. But I think rather than focus solely on that kind of stuff, let's see what it says here in this template, and it'll explain a whole lot more, and we won't have to, argue on some of these other points.
That's cool. That makes me think is if we had stellarium for Mars, and you could go to that plateau where there's the face on Mars and these other weird, strange things that look sort of like five-sided pyramids or whatever they are.
Oh, yeah.
And start working out the geometry of the way the stars look and the path of the sun with alignments of Mars, would you be able to lay out a very similar
You could, but
geometry?
It would be a bit different. Your asterisms would have to change accordingly because your view would no longer be from the Earth. Now, they would be kind of similar. You'd see the same stars, but they're would be different. I don't know exactly to what degree or.
Yeah, that's what I'm saying. You'd have to have the perspective of Mars, and so if we are looking at that layout just from our position, we're looking at what they've done on the surface of Mars. Well, it's not going to match all this geometry because the geometry embedded in the system is dependent on the perspective of where you are when you're building it.
Yes. And on the planet,
and on the planet, and the way the stars look in the sky as you move through time. That'd be really.
Yep.
There you go.
Yeah. So exactly, this is pertinent, and the asterisms that are marked in the sky. Let's just we can just imagine how these asterisms were created was just taking the geometry and saying, okay, this star looks pretty close to being there, and you can choose the star you want, and obviously you or you're monitoring motions of them as well. But so you'll see too where that the asterisms themselves literally point at specific stars and specific points in the template. They're not randomly generated asterisms.
Right, like this one's not supposed to just look like a guy, and that one's supposed to look like a scorpion.
They're telling a story by the what the asterism is,
yes,
the figure or whatever. They're telling a story, but they're also using, like, you're going to be shocked when you see. We're going to be looking at the view of the zodiac view. That is, we typically view it in astrology. We see the circle with the constellations going around it. We're going to be viewing that in stellarium, and that would be from the center of the ecliptic, or the sun would be at the center of that circle. So again, that's the glyph of the sun is a circle with a point in the center, and that's how we're going to be looking at the zodiac. That's our view of the background stars as we look in the path of the ecliptic, and I think it ranges from 8 or 9 degrees above and below the ecliptic. The stars that fall within that band are the zodiac constellations, and that's again how this Regulus, that circle of the ecliptic, which Regulus is on, they measure using Regulus, the regulator, as the motions that goes around that circle.
Yep. All right, man. Well, we are out of time. So this has been a fantastic conversation, and we definitely need to have you back and to dive deeper into it. But tell everybody where they can find you and your work and where they can get your book.
Okay, yeah, you can find me at the gizatemplate.com is my website. I don't really have it updated too often, but there is some pertinent articles and connections there, and you can get my book directly from Amazon there, connection to my site. I do have a couple of YouTube, there's two Giza Template YouTube channels up there with a couple of interesting things there. I'm trying to get some stuff built up there, but I'm right now. I don't have an email hooked up through my website. I apologize for that. I'm going to be working on getting that reset shortly here, but you can reach me through. Let's see. Well. I don't have a email I can give you right now. I don't know what it's going to be on the website yet. So
we'll be able to get it. We'll be able to get it from you next time, maybe.
Yeah, I'll be in contact here, and we'll put it up at another date. But there's a lot of stuff on the internet. Just Google my name. I've been on some radio programs. I've been on with Jimmy Church quite a few times.
Oh yeah,
there's a lot of you can really get some background if you want to listen to a few of the shows I've done with him.
Very cool.
All right, fantastic.
Yeah, we'll update if once you get that email, we can let everybody know. So, and then of course we'll have you on again and keep going into this.
Yeah,
ASAP, and we got a lot more to cover. I'm sorry we didn't really get quite as far as I wanted to give you the showstopper for tonight, but that's okay. We'll we'll save that one for the next show, right?
Yeah,
that's awesome, man. Appreciate it very much.
Yeah, thank you so much, man. Good night.
You guys, talking to you guys, and tell your mom I said hi and sorry I interrupted her there.
That's great.
All right, that was our interview with Ed Nightingale. First one, hopefully in a long series. Fascinating stuff, as we said many times. Many wows and fascinations.
That's right. But it all started with the Zoom meeting that wasn't supposed to happen.
That's right. That's right. So for the podcast, this basically the Brothers of the Serpent podcast has a professional Zoom account, a paid for account, and so the Snake Mom has been asking to basically she's been borrowing the Zoom account to talk to her like college girlfriends. And she was like, hey, can I talk to my girlfriends today or whatever? When are you going to do your interview? And I'm like, yeah, it's not till 8, so it's fine. So I set her up to start talking at like 5:15. And then she gets a hold of me at like 7 o'clock. She's like, when are you doing the interview? Because we're like still chatting. I'm like, well, it's not till 8, so it's fine. And then like 10 minutes before 8 o'clock, she gets a hold of me on the phone. She's like, okay, so like some guy just joined our conversation, and I think it was your interview guy. So Ed pops in there and he's just like, there's my mom and all of her friends, and he's like, is this Brothers of the Serpent?
Totally professional, folks.
Very
100%.
professional. So that's what he was saying there at the end. He was like, tell your mom I said hi. Because they ended up talking for a while, I guess. And she's like, oh, you're going on the podcast. Great.
That's hilarious.
Yeah.
All right.
Yeah, it was hilarious. And the connection was a little spotty. You know, there was some little bit of technical difficulties, but we'll get them worked out. Ed's not in an excellent internet situation right now, so hopefully he'll get that worked out. And but we're gonna keep having him on because it was fantastic. So thank you guys so much for all the support, all the reviews, everybody in the Discord. We love everybody.
Always have.
Always will.
Good night, Adamu.
Get back to work.
Hi, Mom.